Good afternoon, all you fine folks who have decided to hang around late in the afternoon for our presentation. We really appreciate it. Today we have APC uses wireless to automate operator rounds and add predictive maintenance. Standard disclaimer, the information and/or opinions expressed in this presentation are those of the authors and do not necessarily represent official policy or the position of Emerson Global Users Exchange or Emerson Automation Solutions. My name is Terry Folsom. I am the Corporate Oil and Gas Account Manager based in Houston, Texas for Rosemount Measurement. I've been with Emerson now for about 3 years, based out of the Houston area.
My name is David Penny. I'm the Rosemount Account Manager for South Texas, the Eagleford area. I've been with the company going on 9 years. I was 6 years in service before moving over to Rosemount Sales.
Hello everyone, I'm Chris Diaz. I'm APC Automation Engineer. I've been with APC for roughly 7 years now. I have close ties to what we're going to talk about today. When I started with APC, I actually worked in South Texas in the Eagleford, and that's what we'll be talking about a little bit today. Here's the agenda. We're going to go through a company overview, talk a little bit about the mainline facility and its layout, discuss some of the maintenance issues that we're running into out there, identifying the problem that we ran into, site challenges, and talk a little bit about the wireless pressure gauge solution, some of the savings we had on this project, and then a summary of what we found. So talking a little bit about APC, our corporate office is in the Woodlands, roughly 30 miles north of Houston. We're one of the largest independent oil and natural gas exploration production companies. We have offices in Texas, Colorado, Utah, and Wyoming. Our mission statement is to deliver a competitive, sustainable rate of return to our shareholders by developing, acquiring, and exploring for oil and natural gas resources for vital to the world's health and welfare. Our vision is to be a premier independent E&P company, putting our people first, our portfolio, and then providing a great performance. So I'm going to give a little bit of background on this facility. So like I said earlier, when I started with APC, I jumped into this project in the construction phase, wasn't on the inception. So I got to see a lot of the moving parts kicking off when I got down there. This original facility was a gas processing facility, and then we expanded over to the left. As you can see over here, we have 3 30K tanks for our oil processing. Up top we have our pipeline pumps for cells, and then right here this big shed area is actually the offloading bays at the facility. So this area, just a little background on the Eagleford, expanded quite rapidly. I don't think we really understood or really felt that the Eagleford was going to explode as it did, and overnight it grew immensely. Here's the full facility. We expanded it to what you see here. Originally it was down on the bottom left here was the original facility. We doubled that size, and we brought in some sulfur treat, stabilizers, dehighs, some amine. This is our inlet slug catcher, and then these are the 270K barrel tanks, and then our 215K barrel tanks. This just gave us an expansion to process our gas. Also gave us some retention for oil processing. Diving into what we found issues with, the oil storage tanks and booster pumps. We have the 270K barrel tanks that we produce into. The issue we had was with our booster pumps that transfer stored product through the facility to the pipeline. The light oil caused all kinds of issues. We had paraffin issues. As you can see in that picture there over on the left, that's actually where we have our screen. And when we would pull that screen out, there was probably a layer of paraffin on there about 1 inch thick, maybe a little less. Just a green looking layer on there. It didn't look very nice. Some of the maintenance repairs was roughly around $7,000, so it was causing an issue for us.
So the problem that they were experiencing, they were having an issue with pump cavitation. Here we can see just kind of an image of a pump. You can see the impeller inside. Cavitation is the formation of bubbles or a vacuum area within the pump itself. When the impeller is moving, those bubbles collapse, and those collapsing bubbles, it triggers shock waves throughout the pump, potentially causing catastrophic damage to the impeller, bearings, or the casing itself. So what are the causes of pump cavitation? The causes can be anywhere from a clogged screen, which is what they were experiencing at the facility, a blockage in the pipe, poor piping, and/or poor suction conditions. If untreated, as I mentioned, it can cause decreased flow, pump housing damage, destruction of the impeller, excessive vibration, and/or excessive use of higher power consumption. I think this.
So identifying the problem, the use of traditional pressure gauges did not allow them to bring in any of the pressure measurements that they needed into the control room. This also led to additional unscheduled maintenance costs and decreased production. That lack of real-time monitoring resulted in unscheduled downtime, pump damage, and reduced production. So the mainline site challenges, the existing facility design lacked I/O for expansion. Chris talked to this a little bit earlier. Because the facility was piecemealed together, the original idea wasn't for expansion. It was never actually built to be where it is and handling the amount of production that's been coming through there. The lead time to acquire work permits, extensive trenching, and standard wired installation time, as well as the cost of wired installation. So finding a solution. Real-time pressure monitoring was identified as a solution. Being able to monitor the head pressure in real time was going to enable alarms and shutdown settings to be set, which would in turn prevent pump damage. Real-time pressure monitoring also allowed for them to set a preventative maintenance schedule for the pump screens to get someone out there when the pressure reading was low and prevent pump cavitation. So the wireless system solution that was chosen was a wireless pressure gauge and a 1410 gateway. The wireless pressure gauge is what they're using to bring in the real-time measurement. That allowed for that measurement to come into the control room for remote monitoring. This also allowed for them to program those shutdown alarms, which will protect and extend pump life. And also, this allowed for the scheduling of the preventative maintenance. So if you'll look over here on the left-hand side, this is actually the wireless pressure gauge here. You have the 1410 gateway with remote mount antenna. On site, from the aerial that Chris showed you earlier, the two 70,000 barrel tanks at the front of the facility and the 15,000 barrel tanks all have light oil booster pumps that are measuring head pressure coming off. So in line with the 9 light oil booster pumps, we placed 9 wireless pressure gauges. Due to the distance between the furthest wireless pressure gauge and the ones on the 15,000 barrel tanks in the back, it was necessary to install 2 1410 gateways. Kind of a fringe benefit of that is now, as opposed to having a 25 instrument capacity, Anadarko has some real room for expansion there with 25 per up to 50 instruments. We have additional equipment listed there We've presented two different presentations here. It was too much information to really throw into one. We wouldn't have done it justice. But the other was over an X-well installation that came as a byproduct of the wireless pressure gauges. There was some temperature measurement that was needed there. I/O was still a restriction with that, along with some hot tap installation that they were trying to avoid. So there were 3 X-wells that were installed and brought into one of the gateways. And there's also a 702 discrete switch, which has been installed. And that is basically relaying back from a switch and telling the operators when to turn a pump on.
So here we can see an image of the wireless pressure gauge. It's can be configured anywhere from the factory to measure vacuum up to 4,000 PSI. There's a lot of different ranges it can be set up to from the factory. It's got a 4.5-inch display with a dial on it. The dial is updated every 4 seconds. It's got a 10-year battery life with a 60-second update rate, and it uses wireless HART technology. Here you can see in the bottom left, or the center of it, you've got the on-off switch. It comes with the battery installed, and you've got the connections for establishing communication via Trex or AMS to do configuration. Now we're going to show you a comparison of the wireless pressure gauge and a traditional pressure gauge. Here you can see the traditional pressure gauge. Now this wasn't on their site in particular, but you can see the gauge is jumping around, and they've got it matched up to a Rosemount transmitter and the stability of it. Next you can see the wireless pressure gauge, and it's installed. It's more stable reading, and it's more accurate to the pressure transmitter that's installed. So along with the wireless pressure gauges, we integrated those into a 1410A gateway with a remote mount antenna. The 1410 uses wireless HART. It's self-mesh organizing. This particular unit is DIN rail mount, runs on 10.5 to 30 volts DC. You can communicate back to the PLC, DCS. You can communicate via TCP/IP or Modbus 485. And you can configure it very easily through a Windows computer using Internet Explorer. So here's an image of the AMS wireless snap-on. This is something that you can download to a Windows computer. Once downloaded and operational, you can take a Google image of your site, populate that into AMS wireless snap-on, and then do a mock layout, drop transmitters into place, so you can see, kind of get an overview of the site and the network that you would be installing. And here you also see just kind of a guideline of the distances that we can transmit that signal back to the gateway. A standard antenna is around 750 feet. If you move up to the extended range and the high gain, you can go anywhere from half a mile up to 1 kilometer. So here's another aerial image of the facility itself. You can see the first gateway that we installed is here in the bottom center, and we've got 6 wireless pressure gauges reading the pump, the vacuum, or the pressure on the pumps themselves. This distance was about 600 to 700 feet, which would have led to extensive hydrovacing or trenching. Over here towards the center, you can see where gateway number 2 was and where we have wireless pressure gauges 7 through 9 to make sure we had adequate coverage, like Terry was mentioning, for the facility. Gateway 1, gateway 2, back here in the top right-hand corner, that's where we have the X-wells installed. and the 702 is actually back over here into this corner. Here you can see an image of the 1410 gateway installed, the 485 connection down at the bottom, and the TCP/IP connection. The antenna's mounted about 15 feet in the air. And so here we see the wireless pressure gauges installed in front of the pump here. The screen, you can barely see the flange right there. The screen is inside here. We've got the wireless pressure gauges installed. Since it's got the same process connection as the traditional gauge that was installed, installation was done with basic hand tools. Once installed, to get it to join the gateway, first you go into the gateway, pull the network ID and join key, essentially the username and password. Once you have that information, connect up via 475 or a Trex or AMS. Go in, program the network ID and join key. Once it joins the network, go back to the gateway and connect up to set up your Modbus communication and also set up your Modbus table to establish communication with the host itself. So once all the devices joined the network, they connected their host system, or not the host system, they made a connection, TCP/IP, back into the control room. So this is an actual screen capture from the control room itself. This is the same image that you would see if you connect up in the field via TCP/IP. But they can do it from the control room in the technician office. So you can see all the devices and their tag names, and they're able to see the raw data as it comes into the gateway and before it's transmitted out to the host system. Over here on the right-hand side, you can see the last update rate. So if for some reason it wasn't updated, a couple hours ago or something like that, you'd see it. But that's what that shows. They can also use that for in the instance that they want to join additional devices to the gateway. They don't have to hook up from the field. They can program it, put the device in the field, and it will come in here. They can do any configuration from their office.
So addressing site challenges. As we talked about earlier, if you want to sum it up, the majority of the challenges that were going to be faced were based on installation. And the wireless allowed for an efficient installation with no additional I/O that was required because all the communication is through TCP/IP, or in this case, Modbus 485. The costly hydrovac trenching, which is actually required by Anadarko on these sites, and long wire runs were eliminated. The installation and startup time was greatly reduced, and traditional wired installation costs was eliminated altogether. So automating operator rounds. With the wireless pressure gauge, it provides remote monitoring of the pressure going into the light oil booster pumps from the control room without having your operators actually go out into the field, eliminating the need for manual operator rounds. There's a reduced safety risk by limiting exposure to slips, trips, and falls. And as many of the other producers out there, I'm sure Anadarko is not the only one, they have safety initiatives to get guys off of tanks and really limit the amount of time that these guys are spending in the field. It keeps operators out of hazardous areas. Predictive maintenance. Wireless monitoring of the pressure allowed for set point shutdown alarms to be programmed into the PLC. Predictive maintenance can now be scheduled using that pressure set point, reducing the risk of pump cavitation, unscheduled downtime, and extending pump and motor life. From one of the engineers on site there, one of the interesting challenges that they had with the maintenance schedule was they have these manual gauges that are installed, and as we showed in the video, it's kind of hard to get an accurate reading when you're going out there and your needle's bouncing around. And also on top of that, one of the challenges they faced is that contaminants and paraffin and slugs coming through the oil line that doesn't necessarily build up in a consistent manner. It doesn't, you can't say, well, you know what, every 6 weeks we're going to have a nice half-inch film on our screens. He said sometimes that may take 6 weeks and sometimes it may take 6 hours based on the oil that's coming through there. So this is allowing them to monitor that pressure, and when they see it hit that set point, they go out there, clean the screen, and avoid the downtime. Business results. What we did was we sat down with the engineers who have extensive experience with this and put together some conservative, these are Chris's words, conservative estimates on what it would have cost to do a wired solution there. Roughly 320 labor hours, instrument and wire cost, and total wired solution installed cost would have been roughly $87,000. With the wireless solution, the installation time was cut down to 5 hours. David and I were actually on site for that, and the instrumentation cost was $9,875 for a total wired install cost of $10,375. Anadarko captured a CapEx savings of $76,625 on this project, and also eliminated over 300 field labor hours. OpEx cost reductions, this was primarily tied to pump maintenance. The feedback that we got from the operators was, had they continued on the path they were on, over the last few years, they had had roughly 3 pumps a year go down for either maintenance, repair, or replacement. An average of about $7,000 per incident. So in reduction of that, we're going to say $21,000 a year in annual reduction in pump repair. So Emerson has a broad wireless offering these days. At this facility, because we have 2 gateways that are now installed, they have the expansion capabilities that they did not have prior to that. They have actually already taken advantage of that, as we mentioned earlier, with the X-Well, as well as the 702 installations. And David is currently working with one of the site engineers on a guided wave radar application for some tank level out there with the 3308 wireless guided wave radar, which is the equivalent of our 5300 series in the wired solution. So in summary, the Rosemount wireless technology was used to capture real-time input of pressure for the light oil booster pumps and bring that into the control room for remote monitoring. It allowed them to automate their operator rounds. Installation and startup of the wireless system was quick and efficient, and use of the wireless technology saved them $76,000 compared to traditional wired installation costs. And most importantly, the predictive maintenance schedule has been implemented, and they're keeping their screens clean and keeping the pumps up and running. Additional information can be found at the Emerson Wireless site or also the Anadarko site that are listed here. Do you guys have any questions for our panel of experts to my right?
Is the wireless transmitter, is that class 1, div 2? Class 1, div 1?
Class 1, 2, 1.
Class 1 div 1.
Yeah.
Class 1, div 1. And then how about the gateway?
The gateway is in the enclosure, so it's not.
It'll be outside a classified area.
So it's in an enclosure, it's not intrinsically.
Correct. It's one of their panels. The first one is in one of their panels just outside, and then the other one's inside a building, inside the MCC building.
And did you say it was 700 feet away?
It's about 700 feet away
From the gateway
to the furthest wireless pressure gauge.
Okay. And then one last quick question. Did you say that they were basing the decision point on changing that pump suction screen just based on, it's got to be some pressure differential? What was the parameter they were using to change the pump suction screen? I didn't quite pick up.
I think
You can speak to it.
Yeah.
Yeah, so we were monitoring it by the pressure gauge that we had out there. We had an Ashcroft pressure gauge that we were using that wasn't very accurate and wasn't giving us, so we had rounds that we had the operators going on to monitor it. And we were trying to automate that and reduce the operator from having to go out there, and then also introduce the preventive maintenance that Emerson was offering.
So you have your screen, your wireless pressure gauge, then your pump. They took a pressure reading when you had full flow coming through the screen, and then basically you had some pressure readings just above vacuum. So I think they set it at like
1 PSI.
1 PSI. So when,
Suction side of the pump, but downstream of the screen.
Correct.
Between the screen and the pump itself.
correct,
On the suction side.
Correct.
correct.
What was the polling rate that you mentioned that you're utilizing on the WDGs?
60 seconds.
Okay. And that is the minimum polling rate for that device?
That's the minimum polling rate for the wireless pressure gauge.
So on determining the locations for the gateways, what's, didn't catch it, what is actually in those buildings or those locations that said this is a good location to put a gateway in for us? Is it a PLC that's already there? Or?
So we have remote I/O cabinets,
Okay.
and we had space to put a panel, and that's where we placed the gateway. So we did it outside of the classified area, and then in an area that we already have remote I/O.
Okay, and was there a consideration made to doing, say, a larger capacity gateway and attempting to put transmitters to create hops to reach further distances? Because that's a conversation that so many people want to have. It's like, well, I only want one gateway. We'll put some repeaters in and blah, blah, problems are solved. So I'm curious.
That was a conversation that we had. Let me see if I can go back. We'll take a look at the aerial. So when you look at the aerial here, you have a gateway here. This was the first gateway that was installed. So between here and there wasn't really, there wasn't a place. There wasn't any infrastructure there. It was wide open space. So the conversation was based around, what's it going to cost to install a pole, to put something here that we can mount something on, and the gateway was just a more cost-efficient option in this particular instance.
Well, I applaud your decision because that's the right way to do it. I mean, that's a case, especially with tanks in general. It seems to be a common threat that, the gateway is always on the outskirts. It's never in the middle of the tank farm, or in your case, area, processing area, and it's a much cleaner fit to have it like that. So the smaller gateways, the 25-point gateways, you feel like that gives you enough expansion for the amount of equipment that you have in that area in the future? Then?
Definitely.
Okay.
Well, thank you for your attention today and for attending, and we appreciate you listening to our story. Thanks.
Thank you.